Good morning to all. I am Romila, Assistant Professor of IT, the Department of Information Technology at Sri Muthukumar Institute of Technology. I handle the subject, the semester Theory of Computation. The subject code is CS3452, the regulation 2021 in the second year IT students. The core outcome of theory of computation is CO1 construct automata theory using finite automata, CO2 to construct models of regular expression and languages, CO3 to design context-free grammar and full-stone automata, CO4 to understand Turing machines and their capability, CO5 to understand undesirability and NP class problems. The syllabus for Theory of Computation, Unit 1, Automata and Regular Expression, Unit 2, Regular Expression and Languages, Unit 3, Context-Free Grammar and Full-Stone Automata, Unit 4, Normal Forms and Turing Machines, Unit 5, Undesirability. This unit 1 is automata and regular expression. The continuing part of topic is finite automata with epsilon transition. It means the epsilon transitions in NFA are given in order to move from one state to another without having any simple from input set. Consider the example for NFA with epsilon, Q0 and Q1 and Q2, the three states. In the Q0 state is going to Q1 with input of 0 and epsilon, and the q1 is going to q2 the input of 1 comma epsilon, and then q0 is loop state is 0, q1 loop state is 1, q2 loop state is 2, and q0 goes to q2 in the input of 1. And the definition of NFA with epsilon. The language L accepted by the NFA with and denoted by M, and the tuples of 5, Q, summation, delta, and Q naught, comma F can be defined by let M equal to already know Q, epsilon, and delta Q naught F. Where Q is a finite set of states and summation is a input set, and del is a transition and mapping function for transition from q into 2 power q, and q naught is a start state and f is a set of final states. The f is belongs to capital Q. The example for construct NFA with epsilon with accepts a language consisting the strings of any number of A's followed by any number of B's and followed by any number of C's. The solution for the diagram is a start state is Q0 and Q1, Q2 is the three states and the loop state is A, and then going to epsilon Q0 to Q1, and Q1 loop state is B, and then Q1 we are going to Q2 in the epsilon and loop of C means the any number of A's followed by any number of B's and any number of C's. The transition table is given by and the state and the input symbols are state means Q0, Q1, Q2, and the input is A, B, C, and the epsilon. So Q0 going to A in the Q0 states. There is a loop state. So Q0 is B going to the no nothing states. So by and then Q0 equal to C, so going to no states, so given by, so Q0 is a epsilon going to Q1, and then the second set is Q1. Q1 is going to A means no nothing state, so by, so Q1 going to B, and the is state is Q1, so looping states. Q1 going to C is a nothing state, so by, so Q1 going to epsilon is Q2 states, and Q2 third state is Q2, and then Q2 going to A means no given state, so by, Q2 is going to be no given state, so by, so Q2 C states is a loop state, so by Q2, and Q2 epsilon means no states equal to by. And then the next concept of definition of epsilon closure. Epsilon closure means the set of all states that can be reached from a given state by using only epsilon transitions, including the state itself. The one example for Find x epsilon closure for the following NFA with epsilon. The solution for epsilon closure of Q naught equal to Q naught, comma Q1, comma Q2. The epsilon closure of Q1 means Q1, comma Q2. The epsilon closure of Q2 means Q2 only. The equivalence of NFA with epsilon to NFA without epsilon, and given for one problem. So Q naught, Q1, Q2, say three states. So Q naught is a loop state is 0, and the Q naught going to epsilon is Q1, and Q1 is loop state is 1, and Q1 and going to epsilon is Q2. The Q2 is a final state, so Q2 loop state is 2. And the solution for above problem, step 1 is we will first obtain epsilon closure. So epsilon closure means epsilon reachable from states from current state. So epsilon closure of Q naught means Q naught comma Q1 comma Q2. The epsilon closure of Q1 equal to Q1 comma Q2. The epsilon closure Q2 equal to Q2 only. And the step 2 is now we obtain epsilon delta dash transition for each state and each input symbol. So del dash q naught comma 0 equal to epsilon closure of del dash of q naught comma epsilon comma 0. So epsilon closure of del of epsilon closure of q naught comma 0. And the epsilon closure of q naught we already know. So q naught comma q1 comma q2. So next one, the epsilon closure of del of epsilon closure means q naught comma 0 and union del of q con comma 0 and union del of q2 comma 0. So epsilon closure q naught comma 0 is a q naught, and union epsilon closure del of q1 comma 0 is a no state, so by. So and union of del of q2 comma 0 is a no state, so by. So in the given state is epsilon closure of q naught means already know q naught comma q1 comma q2. So next del dash of q naught comma 1 equal to epsilon closure of del dash of q naught comma epsilon comma 1. So epsilon closure del of q naught comma q1 comma q2 comma 1. So epsilon closure of del of q naught comma 1 is a no given the state, so pi union and the del of q1 comma 1 so going to q1 state, so put q1. So union del of q2 comma 1, so no given state, so by. So epsilon closure of q1 means q1 comma q2 only, and the del of q1 comma 0. So already know formula epsilon closure of del dash of q1 comma epsilon comma 0. So epsilon closure of q1 already know q1 comma q2. So q1 comma 0 and union of del of q2 comma 0. So these are no given state, so pi means the epsilon closure pi means pi. So del of q1 comma 1 already know epsilon closure of del dash of q1 comma epsilon. Epsilon closure of q1 already know q1 comma q2. So q1 comma 1 the union of del of q2 comma 1. Q1 comma 1 is going to q1 state, union of q2 comma 1 not given the state, so pi. The epsilon closure of q1 means already know q1 comma q2. So and the del dash of q2 comma 0 means q2 comma epsilon comma 0. So q2 comma epsilon closure of q2 already know q2 only. So epsilon closure of q2 is q2 comma 0 no given the state, so pi state. The del of q2 comma 1 equal to already know epsilon closure of del dash of q2 comma epsilon comma 1. So the q2 epsilon closure of q2 means q2. So then the epsilon closure del of q2 comma 1 not given this no state, so del dash of q2 comma 1 is a pi state. So now and then next del dash of q naught comma 2 means epsilon closure of del dash of q2 comma epsilon comma 2. So epsilon closure of Q naught means Q naught comma Q1 comma Q2 comma 2. So next step is Q epsilon closure of del of Q naught comma 2 union of del of Q comma Q1 comma 2 union of del of Q2 comma 2. So epsilon closure of Q2 means Q2 only. So del dash of Q1 and 2 equal to epsilon closure of del dash of Q1 comma epsilon. So comma 2. So epsilon closure of Q1 already know. Q1 comma Q2. So epsilon closure del of Q1 comma 2 union delta of Q2 comma 2. So epsilon closure del of Q1 comma 2 is a no given state. So pi union del of Q2 2 states going to Q2. So epsilon closure of Q2 only Q2. So del dash of Q2 comma 2. So epsilon closure of del dash of Q2 comma is epsilon comma 2. So Q2 of epsilon closure is Q2 only. So the epsilon closure Q2 is Q2. Now we going to summarize the computed all the del dash of transition. So del dash of Q0 comma 0, Q0 comma Q1 comma Q2, and then del dash of Q0 comma 1 is Q1 comma Q2. Del dash of Q0 comma Q2 equal to Q2. So del dash of Q1 comma 0 the pi state. Del dash of Q1 comma 1 equal to Q1 comma Q2. The del dash of Q1 comma 2 equal to Q2. The del dash of Q2 comma 0 is a pi state. Del dash Q2 comma 1 equal to pi state. Del dash Q2 comma 2 is a Q2 state. The final answer is we can write the transition table. So state is Q0 Q1 Q2. So in the epsilon closure Q0 Q1 is all the states are um, given Q2 final state. So all states are final states. So Q0 Q1 Q2 is a final state. See input symbol 0 1 2. The Q0 goes to 0, Q0 comma Q1 Q2, and then Q0 1 goes to Q1 comma Q2, and Q0 2 gives to Q2 only, and Q1 0 goes to 0 pi state, and the Q1 goes to 1 is a Q1 comma Q2, and the Q1 going to 2 is a Q2 states, and Q2 0 means no states given. So pi states. Q2 1 is a no states. So pi. Q2 2 means is a Q2 states. And the last one final NFA will be a Q0, Q1 and Q2 is a final state because epsilon closure Q0, epsilon closure Q1 and epsilon closure Q2 contains final state of Q2. The diagram means Q0 transition table to given the diagram Q0, Q1, Q2 is all the final states. So input symbols is Q0 equal to Q1 0 and 1 a. Q1 state is Q2 1 comma 2, and then Q0 state is Q2 is a 0 1 2, and then all the states are loop states. So Q0 is a 0 loop, Q1 is a 1 loop, Q2 is a 2 loop. Thank you so much.